Welcome back to Applied Algebra. We're moving on in Chapter 10, the factoring chapter, and we're moving into finding the product of two binomials. Now I know your book says to do this mentally, and you're welcome to do it mentally if you want to. I'm going to show you three different methods that you could do it with. I can then give you more examples of each one if you want, just request it, or you can go online and look at those methods if you want, or just practice them yourself. So the three methods that I'm going to show you are U, which stands with each, and stacked, and the box method. So we're going to go ahead and do the each with each first. This is my preferred method. It's the one I do if I'm going to show something for work. And so the idea with each is that I'm going to take each term and multiply it with each term of the second, whatever the parenthesis is. So I'm going to take this term here, which is 3x, I'm going to multiply it with the 4x and the negative 5. So each term in the second one. And I tend to write them out. So I'm going to do 3x times 4x, which is 12x squared. And then I'm going to do 3x times negative 5, which is negative 15, and the x. So I've taken the 3x and multiplied it with each of those. Now I'm going to take the next term, the negative 8, I'm going to multiply it with each of the next terms. So negative 8 times 4x, negative 32x, negative 8 times negative 5 is a positive 40. So each term in the first expression gets multiplied with each term in the second expression. Now the reason I like this method is because it works for a monomial, a binomial, a trinomial, and any combination of them. So now what I'm going to do is I have these terms here on the end, and I'm going to go ahead and look through them and combine like terms. So my 12x squared is the only one of those. I do have two x terms, so negative 15x and minus 32x is negative 47x, and I only have one constant, so it's plus 40. So that is my answer. So that's the U method, each with each. So the second method is the stacked method, and it's a lot like when you get to multiplying with multiple digits, like 147 times 23 or something like that. And so if you like to work with things in that vertical motion, then you might like this method. So I have x plus 5 and 4x plus 6. So I'm literally stacking them. So I'm going to multiply 6 times 5, and I get 30. So I went this direction. Now I'm going to do 6 times x, which is 6x. Now just like when you're multiplying, we got to move over if you're doing the algorithm. So now I'm going to do the 4x times the 5. 4 times 5 is 20x, and I'm going to do 4x times x. 4x times x is 4x squared. Now this x is just making sure we moved over, so there's not really an x there. Now when I combine my like terms, they're stacked. So I have 4x squared plus 26x plus 30. Now, it's really not that much different than the first method. It's really just how you organize your data. And you'll see that too with this third method, the box method. So when we're doing the box method, again, it's just a matter of organizing it. So I'm literally going to make some boxes. X plus 9, it doesn't matter if you put it on the top or the bottom. X plus 6, doesn't matter if you put it on the left or the right. The idea is that we have a box that is being created by this x and this x. So x times x is x squared. Now this box is being created by the 9 and the x, so x times 9 is 9x. This bottom one is being created by the x and the 6, so that's 6x. And this bottom right-hand box is being created by the 9 and the 6, so that's a positive 54. Now if you use this method over and over again, your like terms, you'll notice, are always in this diagonal. So our final answer is x squared plus 15x plus 54. So go ahead and pick the method you like, practice with it, definitely work on the odd ones. Then if you're feeling good, then you can go back and work on the evens. So have a good day and let me know if you need anything else.